So in this lab we measured off-axis aberrations. Specifically we measured coma and astigmatism.
So here we have our setup all aligned. We have our beam expander spatial filter setup, our mirror. Here we have our test lens with our Hartmann mask in front of it, and then our microscope, which is currently at marginal focus. So as I translate along the z-axis, we can see that we're moving towards marginal focus. As these marginal rays collapse in on each other, we reach marginal focus when this interference mesh grid appears.
For reference, we again numbered the holes in our Hartmann plate. 1 is the center, and then 2, 3, 4, and 5.
For measuring coma, we blocked all but one hole, either hole 2, 3, 4, or 5, and moved the microscope laterally to recenter the crosshair on the beam. For measuring astigmatism, we allowed light either through holes 2 and 4 or 3 and 5, and then moved the microscope laterally again to make sure the crosshair was centered, and also axially to make sure the 2 points were together.
So here is the equation for the wavefront error in coma. W131 is our coefficient, H is the field height, rho is the radial position of the pupil, and theta is the angular position on the pupil. The coma shape comes from the variation in the rays of the field height. At A and B, we have our rays on axis, and they focus at the paraxial image plane. As you move further off axis to the orange rays here at A and B, the paraxial ray focuses a bit higher, and our rays A and B focus above that. If you were then to rotate this about the entire 360 degrees of the pupil, you trace out a circle. At the light blue A and B, again, everything shifted up higher, and rays A and B focus even further above the paraxial ray, which gives you a larger circle. So as you can see, the magnification is changing as we change location of the pupil. So as I said, the theta term here describes the angular location on the pupil. So if you take, for example, orange ray A here, it hits the edge of the pupil at 0. If you rotate it by pi, it becomes ray B, which then focuses up at, again, 2 pi or 0, and so you get 2 theta motion in the image plane after a theta motion on the pupil.
Here's a ray diagram explaining astigmatism. You have your off-axis object point source, and you have your tangential rays forming a vertical line at your pupil, and your sagittal rays form a horizontal. At your tangential focus, you have your tangential rays focused to a point, and your sagittal rays will create a horizontal line because they are still converging. At your sagittal image, you have your sagittal rays focused to a point, but your tangential rays are now diverging, and you get a vertical line. There are 2 different types of astigmatism. One is due to manufacturing error, where the power will depend upon which axis you're on. And the other is inherent to any optical system, where on axis your pupil will look like a circle, but as you move off axis it becomes more of an oval, and off axis the other direction. This apparent change in shape of the pupil is what causes the change in power.
At sagittal focus, points 2 and 4 were brought to focus, while 3 and 5 defined our line. And at tangential focus, points 3 and 5 were brought to focus, and 2 and 4 defined our lines. And then we determined the distance between the 2 foci. To measure coma, we measured the distance between the paraxial focus point O and the focal point of marginal rays A and B. As our field increases, magnification increases, which means ideally our A and B would move further away from the paraxial.
So using our experimental data, we were able to calculate the wavefront coefficients, W131 for coma. We used both the tangential and the sagittal data. Now all of these coefficients should be the same. It shouldn't vary with field, and it shouldn't matter if it's sagittal or tangential. We ended up with large amounts of error. Now we also found for astigmatism that the wavefront coefficient, we found different values, which also ended up with a large amount of error. This could be due to poor alignment, especially poor alignment in different directions. So next we plotted our aberrations, coma and astigmatism as a function of field. Now we know that there are significant errors in our data because coma should vary linearly with h, while astigmatism should vary as a function of h squared, and these plots do not show that.